Hi everyone, back to object-oriented programming. So, when last we looked at things, let's actually look at this. I went over a bunch of string examples and I compared normal strings and C strings, well, normal strings, C++ strings and C strings, and showed the difference between these two different kinds of functions. We also looked at cin and cout for the first time, and now you're allowed to use cin and cout to your heart's content, even though many of you were doing that anyways. The reason we were not looking at this before was because these are objects. When we have a string object, it has certain things, and you can call functions associated with that object. When we have cout and cin, we have these operators like this uh, double chevron thing here, right? So you're taking the string here, please enter your name, and sending it to cout, but that is an operator that is overloaded and actually wrapped up in the cout. We'll talk about this soon, but I wanted to get to why we had to take this little detour. Because it is one of the first most obvious examples of objects and why we had to hold off on talking about strings until now. So, when we're talking about objects in C++, what we had before was we had structures with a bunch of data in them, and then we had a whole bunch of different functions. Uh, and the modules of code modules we have normally in C are our functions, and those functions can be pretty much anywhere. Um, so a data module or a file should normally have a bunch of a bunch of functions that are all related to each other, but there's no actual guarantee or mandate for that. So I could put all my sorting functions in one particular file, or I could put half of them in one file and half of them in another file, or I can move around here, or I can move around there. There's no rhyme or reason or requirement to have some order and some organization to my functions. They could just all be in one gigantic C file, in fact. So I wanted to look at the Rect2400 example. Now we're going to actually live code some of this. Let's imagine, for example, that I have some kind of rectangle structure. And a rectangle structure would normally have something like this. We'd have maybe an x and a y position, right? An x, y coordinate, and then we have some kind of width, and we have some kind of height. And maybe you also have a maybe we even have some kind of color associated with this. Maybe this is a rectangle being drawn to the screen. Maybe this is a rectangle for a hit mask, so that when you click something like a button in a video game, or you click a character in a video game, you know that you click that area and therefore that the character should be animating. Maybe it's the clip plane for a video game. It could be any number of things. The key to that, however, is right now what we have is I have to, every time I want to deal with this rectangle, I pass that rectangle to another function, and then I pass this rectangle to yet another function, and then I pass that rectangle to yet another function, and I keep on passing this rectangle to different functions. In fact, we saw something similar to this with the string class we were dealing with in the really long example. If you didn't get a chance to see it, don't panic too much about that. I think it's in the really long example. Maybe it's in the short one, actually, where we pass in a string object into a function, and then we can't pass it back out again. And we can modify that string, but it's actually we made a copy of that string and a bunch of other things happen. What I really want, ideally, what I really want is that the rectangle itself, conceptually, the rectangle itself knows how to deal with itself. So it might have dimensions x, y, width, and height, and it may have a color, but it also has the ability, it may have a function wrapped up inside of it to know what the area of the rectangle is, or what the minimum point of the rectangle is, or be able to, name, sort of figure out if a point is intersecting into the rectangle, let's say, right? These are all potentially useful functions for a rectangle, and I want them in the rectangle, not somewhere else, not some other file. I want them to be wrapped up all in one go. So here's the rectangle, the rect idea. I'm going to have class rect2400, and my syntax. I always forget my syntax here, so please bear with me. I'm going to have int x, or I can call it width, be a bit more specific. Int, and then I may have some kind of color value. Now, I could use an int for my color, so let's, just for the time being, or let's call it something else. It's an RGB color. Since RGB colors are, since RGB colors are, each one of them are the red, the green, and the blue, are each 0 to 255, that would be 3 bytes. But I can't, there's no data structures that are exactly 3 bytes, so I'm going to make 4 bytes, which is the size of an integer. Okay, but what I also want is I want something like, I want something like a function like getArea. And what I don't want, or let's put it all in one go here. What I don't want is to have to define getArea somewhere else and then use a structure. I want the structure and the function to be wrapped together so that I can just use this. And so I could say, here would be the actual definition. What? So I have this variable called width, I have a variable called height. It's in this particular structure, and since we are already in this particular, well, it's not really a structure, it's an object, but since we are already in this object, I can just use that variable width and that variable height. It exists in this space here, right? Between here and here, it exists, and therefore, if I call getArea on a rectangle, it knows how to calculate the area. I don't have to pass in the rectangle. The rectangle knows about itself. So, if I have a rect 2400, let's call it my rect. All right, and I can call my rect dot getArea, and magically I should get the area for my rectangle that I created, much like getting the area for my structure. But instead of having to do a bunch of other stuff, I just put a dot instead, and I don't get the member variables. I can also get functions associated with that particular object. That's the theory. That's the concept. We'll go over it other ways right now. So uh, here, if we want to go back to our linked list example, right? Remove from front. We had some kind of function, and I had to pass in linked list into it like a chump. I had to go and move this data structure around and move it here and move it there everywhere. Why don't I just say, hey, linked list, remove your first element, right? I don't tell, so I get the object to do its own thing. We've already seen this. When you did scratch videos, if you were in my 1400 class last term, you've done this. Every one of those scratch games you were making, you had a particular pixel and or a sprite that you're dealing with, some kind of thing like a fish or a dinosaur in my dino dinner case, right? You say, "Hey, dinosaur, if this happens, do all of these things." Right? It's associated with the actual object, not thrown somewhere else out there in the world. Much like, and if we want to go over another example, I'll just quickly cancel that. If I go over a given button, for example, and I click the button knows now the button should know how to deal with a click event. The button should know how to draw itself. The button should know what the associated text or what the button does. The button is in control over its own fate. It's not intelligent or anything like this. But where is all this stuff involving buttons? It's in the button class. Where's all the stuff involving slider controls? It's in the slider class, and it knows how to deal with itself. That's the concept. It's not just throw your code around willy nilly. It's all code associated with the slider is in the slider class, and every instance of an object of the class, an object, which will differentiate soon, that has its own copy. So every single one of these squares has its own copy of how, and it knows how to draw itself. So when we're talking about structures, we can have different types. We have the structures allow groups, so we allowed us to group our data, so we'd have different types of variables. But as I make a new variable type, I can access the individual member variables, but I don't get functions associated with them. I got to put those functions somewhere else. And in our case, we're just bundling them together. Uh, objects know how to deal with the real data. Now that seems very simple. That's the original concept is relatively simple. And then people quickly realize there's other side effects. There's other nicety. It's not even a negative side effect, it's a good side effect. If I have the object and it knows how to deal with itself, why does anyone need to know anything about what's going on with the object? So, if I have a linked list, or let me take my string example again. How are strings implemented? I don't know. You don't know. You might have guesses that it has an array or something like that in there, but you don't need to know. You just say, hey string, I'm going to update your text. Hey string, how long is this string? Right? You don't have to know that it's storing it in an array. It could be storing it in some other data structure. You don't have to know all the gory details of it. You don't have to expose the underlying data. You just need to be able to use it. So the object knows how to deal with its own data. And then we go even further. We're going to get inheritance so that if I can have strings and I can have special kinds of strings that are slightly different, and I can reuse a lot of that code. We'll also deal with polymorphism so that we know that when we're calling particular functions, we call the right function. We'll deal with all those in the near future, but just laying it out, exposing you guys early on to that you do not need to expose how this thing is implemented. You can have an object, you can have code, and no one has to read your code to use it. And that is huge. You cannot make that assertion almost anywhere else, right? So you have, we did like printf. You don't know how printf is actually implemented, but you got to expose a lot of stuff to say like it's going to be a character array being passed in here, and it's going to be this being passed in here. All the data being passed in, you know exactly what the data is being passed in. Um, So if we make a class for rect2400, it would have rect intersection methods. It might have calculate the area methods. It might or get area, for example. Every instance of a class is called an object. Objects are instances of a class the same way that I am an instance of type human, right? There is no human object per se. There are instances of type human. So the string class describes how strings are formed, but every single string you make is a new object. It's an instance of the class. So those are of type string. Every string you make is of type string, but it is an object. It is an instance of the class. I'll keep on saying that over and over and over again. So the classes and objects are different things. Objects are just the real world example. I think I have an example here. Well, actually, I'll jump ahead and come back. There you go. Duck is equal to new duck. Duck is equal to new duck. And this duck, this this egg of a duck, is an instance of type duck. It is not all ducks. It is an instance of type duck. It is the object, not the class. The class, ducks, is generally a description of all ducks, but it's not an actual instance. It is not an actual thing. It is just the conceptual framework, right? Much like a country. Country, the class is country, the like the concept of what a country is, right? So the class is country. The United States is an instance of class country. Canada is an instance of class country. An object is not the same as the class. Okay, so let's just rehash some over things. Procedural programming is what we've been doing before. You modularize your code based off of functions, and you pull things together based on functions, and it allows you to reuse your code and view it and maintain stuff. Great. But there's no higher level structure either. So we have functions, we can build subroutines, they become their building blocks. There's just a sequential execution path, uh, so top to bottom of your file, but there's nothing saying where this thing has to be. So here would be an example of a procedural programming language, right? foo1, foo2, and main. There are three different functions here. Main knows about foo1 and foo2. Fine. It's just going to go in order. It is the one step after another kind of concept. Getting things like a button is a very different beast. For procedural programming, it can be modular. At least you have functions. It's relatively easy to understand conceptually. You don't have to go, you know, talk ad nauseum about what an object in a class is. It's just a series of or a sequential series of cases. Essentially, it's very practical. It's very easy to do, uh, and you can do some ad lib library and header modeling to sort of hide information, right? You put stuff that you don't want other people to read in some other file, but that still doesn't help you that much. The cons are for really, really big systems, especially systems that have that where the data has to talk amongst itself, to go to different modules, do different things. It really doesn't work well. It works fine for a server side code some of the times, but for like a graphic user interface, this is ridiculous. It does not work in the least for a graphic user interface, right? And we're not going to try and make it for a graphic user interface. So anything with interaction, anything with events, anything with having to have like this concept of a button that you can click, all of that requires objects. Okay, here are a bunch of files, bunch of functions like xfoo, xybar, yfoo bar, and they're in different files. And the question is, what data and functions are related to what, right? Maybe xfoo requires x data and xy bar requires x data and y data and a bunch of other things. And how do you know where you put all those files? Do you organize the functions in alphabetical order? Do you order them? Do you group them based off of, you know, what they're related to? It's just they're somewhat random choices. So if we went back to the student example, right? So I have a function called print student data. Print student data needs to get a structure. You need to pass in the structure for print student data to work. And in order to write print student data or to use print student data, I actually need to have access to a student data structure. And that means other people are going to know how the student data structure was implemented. I shouldn't have to know. And more importantly, I shouldn't be passing around this stuff. So, for example, if it was you as a student and I wanted to find out about your GPA or whatever the case is. Okay, so you're going to go and get your res hall keys or you're going to register for a class. You pass your student data to the system to register for this one class, or maybe you pass in your student data, just all of your student data, all of it, including your GPA, so that you can increase the amount of money on a card so that you can buy lunch on campus, or whatever the case is. That's all of your personal data. There's no screening for who needs confidential information and who doesn't. If I'm passing just raw data to everybody, everybody has access to all of your data. What I want is that I say to the object itself controls who has access to the data. That's what's called information hiding. We're going to see that a lot. So the student, you say, "Hey student, what is your student number?" And they go to hell. You're not, why do you need my student number? Or, "Hey student, what's your GPA?" And they don't need to tell you. The student controls their own data. That's the concept. So who has access, how gets used, because the object it wraps up all of the data and the functions together. You can hide the information. You can hide what's that's actually being stored in the system. Okay, I like maybe I'm overkilling this thing here, but I like this metaphor. This, by the way, on the left hand side is my boys and their playroom. Yes, they take after me in terms of sheer messiness. It is disgusting and really over the top. This is actually the one of the few times my sort of workroom area was actually properly cleaned up. I'd like to point out, if you looked carefully, you can't in a photo of all of my boys' toys and play stuff. It's everywhere in random places. You go to look for something, where the hell do you look? Right? If I am something similar for procedural programming language, right? Where is that function located? I don't know. It can be in any one of like 40 different files. I don't know where that file is located. I have to do like some kind of search in files thing. And I may not know what the name of the file is. I may not know what to be even looking for. The data can be stored and put anywhere at any time. That's one of the problems with procedural languages. It's simple, but it doesn't give you any structure. Versus if I have this area dedicated as my sort of work area, if I want to do something like I'm not exactly overly handy, but like if I need an electrical cord, if I need a staple gun, if I need, pliers, whatever the case is, it's all over here. I have a dedicated place where I know everything is located, one stop shopping. Right? That's what you sort of want. You want to be able to organize things. And you can't do that with a procedural language, at least not with C. You can with C++ because the class itself encapsulates everything. If it's involving with that class, it's in the class. Okay, we've already done this one. So here's my silly metaphor, my silly example, is cars. Now, if you look on the road, imagine if you were trying to control all the cars that were going there. That's a big pain in the ass, right? Like you would have to keep track of every single car, the mileage on every single one of those cars, the pressure on all their tires. You need to figure out how much gas is in each one of those cars, what the speed that they're going, how often they brake, how many people are in the car. Or you could say, hey, each of those cars controls itself, and you just set up the rules, and the cars know how to drive. This is sort of the conceptual framework that we're dealing with. You're not some deity that's going around moving around all these individual parts. The parts move themselves, and something like the green light makes all the cars move, but each car controls its own fate. We also say that cars have particular properties, right? So a car may have an odometer, how far it's traveled. It may have an amount of gas in the car. It may have a number of wheels as a parameter. It could have the capacity, the number of people that fit in the car. You can have the mileage or the miles per gallon for a car. Cars themselves have subclasses, right? There is the Mazda 6 and the Mazda 6 2015, or whatever year you're talking about. Uh, you could have Mazdas and the Mazda 6 as a subclass of Mazdas, right? Subclasses being a smaller set of a much larger set. In fact, cars themselves are a subset of vehicles. Cars, motorcycles, trains, planes, they're all vehicles, right? Uh, and therefore, I've not been corrected on this, so please bear with me if I'm wrong. Anyone that speaks Mandarin, I was told by one of my friends, and I was like, huh. He thought it was kind of curious. if you look at the Mandarin language, the way a lot of times, much like German and a lot of other languages, it's a composed language where you have vehicle and then you have fire vehicle, which is a train, by the way, or you may have a firefighting vehicle, which is a fire truck, or you may have a Western vehicle, which is a bicycle, or you may have, I can't remember what a car is, but it is just this composition of vehicle and the modifier, what it is, what kind of vehicle it is. It's a subclass of all vehicles, right? So cars themselves are a type of vehicle, right? And all vehicles have something in common. They transport things. Cars are a particular kind of vehicle. They should normally have four wheels. Otherwise, it's something else, right? A train has a particular set of characteristics. It drives on a track, and it often has a combustion, some kind of combustion. It may not have a combustion engine, but often would have a combustion engine in North America. Planes fly, for example, right? They're all different, and they have unique characteristics, but vehicles have characteristics that all of them have in common. A Mazda 6 has a characteristic that all cars have in common. All cars have, if all cars have four wheels, uh, then it is a subset of cars and it also gets four wheels by default. So when we talk about inheritance later on, we're going to see this in action where if I make the car class and I make things for the car class, every every type of car, no matter if it's a subclass of car, no matter if it's a special kind of car, automatically gets those functions, automatically gets those variables. So the parent class, when I describe all the functions and all the variables, everybody gets that plus a bit more. Um, I could go over a Dungeons and Dragons example because I'm playing with my boys, but I'm pretty sure that's going to lose most of you, and many of you will steal my milk money. So I don't want to be doing that. So, but the real point is, each car on the road has its own independent set of data and works independently and should be treated that way. Conceptually, it makes a lot more sense to treat the car as the unit than the various parts per car. And treating the car as a unit, it should control its own fate. So it modularizes it based off of some kind of conceptual framework, like a car, right? That I'm dealing, or it could be a packet, or it could be a linked list node, or it could be a Rect2400 class object, right? The we define the programs in terms of a bunch of and each of these things interact with each other. Each car interacts with itself and also interacts with the lights, right? The traffic lights. And so the objects themselves have data and function, and then you have this connections between the different objects, and that's how everything works. We have signals and events so that the object responds to particular events that happen, and the objects themselves communicate with their means of communicating with other objects. Okay, and each car would have fuel remaining, model year, odometer. If I tell the car to drive, that conceptually makes a lot more sense than trying to figure out exactly, oh, how do I make this car drive and how much fuel is it going to use and what's going to change the odometer and stuff like that. And more importantly, I don't want some random other function changing the odometer of the car, right? This is not Ferris Bueller's Day Off. You don't just change the odometer of a car, right? The odometer is not supposed to change by any other means other than going to, I think a mechanic should be able to do it, but it's not meant for people to do the people driving the car to do it. So when I do drive car, it should change the odometer, it should change the fuel, but nobody should know how it's doing it. I should just be able to say drive car and it should work. No one else should have access to it. The car should be on control of itself. And I like to point this out. I don't get to see your responses, but how many of you are car geeks? Most people don't put up their hands. It's really kind of surprising. There are normally some car geeks in a crowd. I have not seen that many in these classes. Kind of disappointing. I am certainly not a car geek. I don't know the first thing about cars, if you couldn't tell from my examples. I don't need to know. I just need to drive the damn thing. I do not need to have to. I don't want to know how to reconstruct an engine. I don't want to know how exactly the internals of a combustion engine are actually supposed to work. I don't want to know how all these various parts are put together. I just want to drive it. That's the benefit of object-oriented programming. I I can just have this object and use it and not have to know the ooey gooey details, the internal uh, bits and pieces for it. I shouldn't have to know much about the car at all, and I should just be able to use it. You cannot do that with a procedural language. I will be passing around large amounts of data, and people will go like, "What's this piece of data do? What's this piece of data do?" It's why you would have to know all the details about everything in order to use this. Okay, so typically, traditionally, what we're going to be doing, what we're really going to be doing a lot more than probably a lot of other classes, every single one, not always, I'm going to start small, but most times when I make a class, I'm going to make two files with every single class I make. I'm going to, and I made a hand sign with two, because, video. Sorry, you're not seeing me. I keep on using my hands, and there's no need. Okay, so I'm going to make two different files per class. So let's go back one, oh, forward one. So I might have rec2400.cpp, and then I might have, if you've taken my classes before, you've seen us do this separation barely, but we looked at this a little bit. We don't have to have everything in one giant file. And so as a policy, what we normally do is we separate into two different parts. We have, this is table of contents, if you will. What you can do with a Rect 2400. It is just the stubbies. It's just the prototypes. It's just the functions and, unfortunately, well, most of the time the variables, but you can also even hide those. It is just the stuff you can do with that class or an instance of that class. And then the actual code is right here. We don't have to do this. We can actually just make a class all in one go, in one file, done. But as soon as these get big, as soon as our projects get big and we have multiple different classes, we absolutely need to take this sort of separated out approach. What this allows us to do is that when I come up with what functions I need, every other class needs to include this, and then this is only compiled once. So it really speeds up the process of how we do compilation and how other classes and other files know about our code. So if I don't include Rec 2400 somewhere, what's going to happen is no one's going to know what a Rec 2400 is, and you're not going to know what the variables are. If I include this, I'll also include this, and then I'm good to go. We'll see it in more examples soon. Um, so really, the big thing is that it's a conceptual framework, and it's meant to simplify your reasoning. So if you choose an object or a class structure that doesn't make sense, that is not intuitive, that other people go, yeah, that's the right answer, right? If you break it up in weird ways that you wouldn't expect, then you're going to screw over everybody that uses your system. I'm thinking of the Kevin James old comedy bit where he says where you have telephone number pace, right? 613-555-2922, right? That kind of beat to it. And if you don't parse it up in that way, and you go 6134-9925-33, right? It doesn't work, right? If you break up the problem into these objects and the objects make sense conceptually to everyone else that uses them, it's easy. Now, these objects may be based on physical things, they may be based on conceptual things, like it's all the stuff for sorting, It could be based off of like a data structure. It could be broken up into a wide variety of different ways. It doesn't have to be physical objects, but conceptually, it's easiest to initially go over that. Okay, so by the way, objects in a class, then the class might be the 1984 Plymouth Horizon. The object of that class might be the particular 1984 Plymouth Horizon I got into two car accidents in. Yes, I'm a terrible driver on top of knowing nothing about cars. They're terrible, terrible cars. Let me also point out, if Plymouth Horizons keep breaking down though, where do I look for a mistake? The first instinct, if you split things up right, if that car keeps breaking down, where do you look? You look in the Plymouth Horizon class. You look in that file. You don't look in the Mazda 6 file, which is somewhere else. You look where the problem is. And this gives you a nice order to how all your code looks. I have a problem with Plymouth Horizons. Go look in the Plymouth Horizon class. That's the first step you take, right? It's not just distributed willy nilly. Okay, so let me do a live coding example for Rec 2400, and then after that we'll take a break, and then we'll go back to objects. All right, because I wanted to show you guys this early enough on. Okay, so here is a bunch of things that we're going to be doing. I have made a very simple, hopefully very simple, and let's put a printf statement in here. You know what? IOStream cout maybe works. The rect is size, and then I'll get okay. All right, and this is I'm using it should be using standard namespace. Does that work? Let's see. Pointer to a function. My rect is here. Rect area. Something wrong going on wrong here. I'm just checking my assert here. So let's see what I got here. No, that's still problematic. Okay, so rect area. My rect is already defined. This thing is local variable. Uh, it's going to return an integer. Parent call must have a pointer to a function type. I might have just something stupid in here. Rect 2400 rect area. I'm doing something really ridiculous almost invariably. Must have a pointer type. Let's just call it rect area 2. Oh, it is because it is a collision. I didn't think they would ever cause a collision between having a variable and the function having the same name. I didn't think that would cause a problem at all. All right, good enough. Good to know. Hopefully this is going to work. Let's find out. And size 100,000. All right, great. Size 10,000, as you'd expect. So I have a rectangle. So this is meant to be a simple little toy example. Let's throw something in. So we're going to comment out all of this stuff. Class rect 2400. And then I'm going to have a private variable. Can I do that? And then I had color RGB. Looks exactly like a struct, doesn't it? Except structs and objects are extremely similar to one another, or structs and classes are very extremely similar to one another. Um, so let's pop that in there, and we'll talk about this public-private thing later on. I want to get rect area. All right, and I'm going to just define it right here. I don't need this rect here. So it might seem like I'm taking even longer to write this thing, but it's it's because I already wrote the other one. Okay, rect area, it's in there, and it's public, and I should be able to make a rect, but I'm not sure if it's going to allow me to do that. Let me do one more thing, and rect 2400. I'll expose you guys to one of my personal favorite things. Um, all right, this is what's called a constructor. A constructor is pretty much only used for, I mean, it's used for creating an object. So when I make a new object, I can, we'll see it in action in a second. I will call this every single time I make a new object, I will call a constructor. And sometimes, especially if I have to make new memories, not new memories, new memory, if I have to allocate memory, I need to call the destructor. So I have a constructor when I need to make something, and I have a destructor when I need to destroy or clean up stuff. So this is going to be a constructor, and I'm going to have x is equal to x pos, y is equal to y pos, w is equal to width, h is equal to height. And you're probably wondering, why the hell am I doing this instead of the old way? Because it is actually much better in the longer run how this thing actually works. So, and this is going to give me an error because I know it's down here, but I want to compile anyways. And my rect is equal, and I'm going to make a new rectangle, and it's going to have 0, 0, 100, 100, and oh, I wanted the color RGB value, so that's going to be 255, 255, 255. All right, so that is a color RGB value. I'm going to call that constructor. I'm then going to call, it's going to be this. I can just call rect area from there. So instead of me passing in a structure or me passing in this and me passing in that, you might think I'm just doing the same amount of work. And in this toy example, it looks like the same amount of work, but it's really not. When I deal with a linked list, which we'll be getting to very soon, we'll revisit linked lists. Instead of passing around linked lists everywhere, I just say, hey, linked list, add this item. No one needs to know how I added that item. I just add that item, or add an element to my linked list. You don't need to know how it's being done. And so other people using your system, it's a much easier time. And conceptually, at least I find it far better to be doing object-oriented programming. It makes sense. The rectangle knows about itself. The rectangle can tell you what the area is. The rectangle can tell you if a point intersects the rectangle, not having you figure out this each and every time. So if you, by the way, if you wanted to try that, we can try something like that. So bool intersect and int x, int y. Okay, so I'm going to see, I don't want to call it p, px, py, px, py. So where the point is. I'm trying to see if a point is in the rectangle. So if my rectangle starts at 20, 20, goes 100, 100, so it goes to 120, 120, right? That would be the with the width of 100 and a height of 100, it'll be go from 20, 20 to 120 and 120. If my point is at position 40, 40, it's inside the rectangle. It's intersecting the rectangle. If my point is at 0, 0, it's not. Okay, so what could I do? I could then say return, it's px is greater than x and px is less than x plus width. Let's say less than or equal. And I'm going to include that. There you go. Okay, and then I'm going to do the whole thing again for the other side for y. Y height py y y. All right. So this will tell me if a particular point is intersecting. And let me make sure I've double checked everything here. Yeah, this should tell me if a given point px and py intersects my particular uh, rectangle, and that should be. I can't believe I put those in the wrong order. Okay, so let's try intersect, and I'm going to try assert my rect dot intersect, and it's at 0. So let's put 40, 40. We should assume that to be true, and I'm going to say not this, and I'm going to make this at minus 40 and 40. That should be false, right? It's not within the bounding box. Or maybe I can make it let's also make it 80, 101. And again, it should not intersect. And I can just run this code. There it is. And I can just run this code and see it. But notice the person calling intersect does not have the foggiest clue how it's used. I can hide this away in some other in somewhere else in another file, and you do not need to know how it's being done. You don't need to know that I'm doing this kind of thing. In fact, that's the point. That if I find out I have a bug here and I fix it, you don't have to be aware of it. If I have a bug here and I don't, and let's say I accept more data than I did before, like or it's more robust, or it doesn't break as often, or maybe it handles things more gracefully. Whatever the case is, you don't need to know. You're still using the same old code as before, the same old functions as before, and yet your code works better. That's You don't have to know how the other person implemented it and hurt your brain trying to figure out what their code does or how it works. You can just use somebody else's code. That's why we do this. All right, let's make sure that it actually does what I think it's going to do. Uh, oh, that should be char. It's a bunch of chars, so I'm going to do that here. There we go. And rec size is 100,000. Nothing blew up. No, none of the asserts failed. Although, if they didn't work properly, those two would have failed, or this would have failed if my intersect did not work properly. Okay, this is the very first step into a much larger world. This is what a basic class will look like. Here's rec2400. I have a bunch of variables, and then I have a bunch of functions associated with those variables, versus having a structure and then having the functions defined somewhere else. When we come back next time, we're going to be looking a lot more at object-oriented programming, including just giving through some more examples and then looking at linked lists again. All right, thanks everyone.